Morning. Today's my lecture topic is the suspension system in automobile. Actually, in automobile, the suspension system plays an important role because whenever the road irregularities comes into play, the suspension system plays an important role because when the damping effect is controlled by this suspension system, the primary function is to absorb shocks and maintain vehicle stability. It improves ride comfort by isolating passengers from road irregularities. Suspension ensures that the tires remain in contact with the road surface. A good suspension system balances ride comfort with handling performance. It absorbs energy from bumps, potholes, and other road imperfections. Suspension systems can be found on both front and rear axles. They also help maintain proper wheel alignment and control weight transfer. The system works by using springs, dampers, and linkages. Common types of springs used include coil spring, leaf spring, and torsion bars. Coil springs are helical steer springs found in most modern cars. They compress and expand to absorb road energy. Leaf springs are made of stacked steel strips and are used in trucks and older vehicles. They support heavy loads and are durable. Torsion bars twist along their axis to absorb force and are adjustable. Springs alone cannot control motion, they need dampers. Shock absorbers or dampers control the motion of the springs. They convert kinetic energy into heat to prevent excessive oscillation. Struts are a type of shock absorber combined with a structural support. McPherson strut is a widely used front suspension design. It combines a shock absorber and coil spring into one compact unit. Double wishbone suspension uses two control arms for precise handling. It is commonly used in sports and performance vehicles. Multi-link suspension uses three or more links for greater flexibility and turning. It offers excellent handling and ride comfort but is complex and costly. Trailing arm suspension has arms that pivot at the front and support the wheel. It is used in the rear suspension of some cars and SUVs. Torsion beam suspension is a simple and cost-effective rear setup. It provides decent comfort but less independent wheel movement. Air suspension uses air-filled rubber bags instead of steel springs. It allows variable ride height and low leveling capability. Luxury and heavy-duty vehicles often use air suspension system. Hydraulic suspension uses pressurized fluid to control stiffness and height. Criterion pioneered hydrodynamic pneumatic suspension system in passenger vehicles. Suspension systems also control body roll, pitch, and dive. Body roll occurs during cornering, pitch during acceleration and braking. Suspension geometry includes camber, caster, and two angles. These angles affect tire contact, steering, and wear. Anti-roll bars or sway bars reduce body roll during turns. They connect the left and right sides of the suspension. Modern cars use independent suspension where each wheel moves separately. This offers better comfort and handling. Dependent suspension links both wheels with a solid axle. It is stronger and used in commercial and off-road vehicles. Front and rear suspensions can differ in design and purpose. Front suspension typically aids in steering and load support. Rear suspension handles weight distribution and stability. Suspension affect ride and ground clearance. Adjustable steer suspension allows the vehicle to adapt to different terrains. Sports cars often use low and firm suspension for responsiveness. Off-road vehicles use high and flexible suspension for articulation. Suspension travel refers to the distance the wheel moves up or down. Longer travel is better for off-road use. Shorter travel suits Road cars. Suspension pump stops prevent over compression springs. Suspension bushings reduce noise and vibration in joints.